All right. So this section's elasticity of demand, economics topic. So that's not my that's not my strong suit. So I just can do the math behind it. But so let's see. It says retailers and manufacturers often need to know how a small change in price will affect the demand for a product. If a small increase in price produces no change in demand, then a price increase may make sense. But if a small increase in price creates a large drop in demand, then the increase is probably not a good idea. All right, so to measure the sensitivity of demand to a small percent increase in price, economists calculate the elasticity of demand. And here's the formula for it. It's negative x times the derivative of x, all divided by, so d of x is the demand function. So it's x times the derivative of the demand function divided by the demand function. These people in. All right. So we'll use that formula. We'll use that formula to compute the elasticity of demand, and then based on that, we'll make one of these choices. So it says for a particular value of the price X, the demand is inelastic if this E of X that we compute is less than 1, meaning that an increase in price will bring an increase in revenue. All right. And if demand is inelastic, then the revenue is increasing. The demand has unit elasticity if E of X equals 1, and this happens when the revenue is at a maximum. And then finally, the demand is elastic if E of X is greater than 1, meaning that an increase in price will bring a decrease in revenue. And if the demand is elastic, then the revenue is decreasing. All right. So those are your formulas. So we're just going to do a couple of questions. Oh, no. All right, so we are told that the demand for DVD rentals at Clicks Video is given by function Q, which probably stands for quantity, but it's also given as a demand function, D of X. So yeah, where Q is the number of DVDs rented per day at X dollars per rental. All right, so we want to find the elasticity as a function of X. Well, the first thing we need to do is get the demand function, get the derivative of the demand function. So d prime of X, that's pretty easy. The derivative of 120 would be 0, and negative 20x, the derivative would be negative 20. So the derivative is a constant. And then E of X, formula, negative X times the derivative of the demand function all divided by the demand function. So we're just doing some substitution. Negative 20 goes in for the derivative, and then the demand function goes in the denominator. And then we'll just multiply negative 20 times negative x will give me positive 20x over the function, the demand function. So next we're going to evaluate this at some numbers, some values of x, but why don't we go ahead and simplify this? We could factor out a 20 from the denominator and then cancel out the 20. That'll make our calculations a little bit easier. All right. Okay. All right, so for part B, find the elasticity at 2. So I figured out how to make this not jump around. So we'll call that E of 2. So that's going to be 2 over 6 minus 2, which is 1/2. All right, so in this case, E of 2 is less than 1. So go back up to the how we interpret this. We have the first case here. The demand is inelastic, meaning that an increase in price will bring an increase in revenue. Okay, so interpret the meaning. All right, so I would just say something like demand is inelastic. All right, and then E of 4, so that's 4 divided by 6 minus 4, which is 4 divided by 2, which is 2. And 2 is greater than 1, so E of 4 is greater than 1. This tells me that the demand is elastic. All right. Okay, and then I guess we could also add here revenue. If the demand is inelastic, the revenue is increasing. And if it's elastic, the revenue is decreasing. Okay. Then part C says find the value of x for which E of x is 1. So up here is our reduced formula for elasticity. Let's write that right here. E of x is x over 6 minus x. So we want to set that equal to 1. And solve for x. So I'll do that in the next step. So this is an equation with a fraction in it. We want to get rid of the fraction, and we can do that if we multiply both sides by 6 minus x. That leaves me with x on the left, 6 minus x on the right. I'll add x to both sides, which gives me 2x equals 6 or x equals 3. All right. So when x is 3, the elasticity is 1. All right. So go back up here. Remember, x is the price for renting a DVD. So I would say something like when the price to rent a DVD is $3, the revenue, well, we call this unit elasticity. So the revenue, since I started that, the revenue is at a maximum. And I guess we could say the demand has unit elasticity. All right. Or my voice. Okay, then part D. Find the total revenue function. All right. So there's the formula. The revenue is x times d of x. D of x was way up here as 120 minus 20x. All right. Okay, and just distribute the x, gives me 120x minus 20x squared. So that's my revenue function. And then part E says, okay, now find the price X at which the total revenue is a maximum. Remember, this will occur where my derivative equals 0. All right, so let's get our derivative. For 120x, the derivative is 120. And then for minus 20, I'll multiply by 2, minus 40, subtract 1 from the power, leaves me x. So there's my derivative, and I'll set that equal to 0. Divide both sides by 40. Gives me x equals 3. All right, so basically, I mean, that just coincides with what we got up in part E, or part C, sorry. That when the elasticity is 1, that's when the revenue has its maximum. And we also got that same information by finding where the derivative equals 0. Okay, so say that's the same result as part C. Okay, now with me? Yes, yes, no, yes, no. Okay, so like I said, this is a pretty short section. Let's do example 2. For the demand function that's given, X is the price and Q is the quantity. We want to find the elasticity. All right, so Q is also the demand. All right, so we can say D of X. We need to solve that equation for Q. Okay, so up here, first thing I'll do is subtract X. And then divide both sides by 4. What was this thing? Oh. Oops. All right, divide both sides by 4. So Q is 80. Let's do it this way. 80 over 4 minus X over 4. So let's write this as 20 minus, instead of X over 4, let's write that as 1/4 X. All right. So that's my demand function. Put that down here. So D of X is 20 minus 1/4 X. Let's see if I can bump this down. All right, because we still have to find the elasticity. So remembering our formula, it's going to be E of X equals negative X times the derivative of the demand function divided by the demand function. So let's get the derivative of the demand function. Again, for 20, the derivative is 0, and for negative 1/4 X, the derivative is negative 1/4. So substituting up here, I'll put negative 1/4 for D prime. And then my demand function in the denominator of this, 20 minus 1/4 X. I don't know, it may make more sense to write those as decimals. So negative 1/4 is the same as negative 0.25. And when I multiply the negatives together, hang on a second. Oh. That becomes positive 0.25. And then we'll write in the denominator, we'll write that again as 0.25, probably just make things easier. So that's my elasticity function. Part B says, again, at what price is the elasticity of demand equal to 1? So we need to set that function that we just found, we need to set that equal to 1. And then, like we did before, I'm going to multiply both sides by the denominator of that function, which is 20 minus 0.25x. What's going on here? Just add an O. So what I'm doing here is multiplying both sides of the equation by the denominator in order to remove the denominator, okay? easier to solve. I mean, that's how we solve an equation with a fraction in it. So that's gone. Get a little more room here. Okay, so that leaves me with 0.25x on the left side, 20 minus 0.25x on the right side. And I'll add the 0.25x to both sides. And that's 0.50 or just 0.5. And then finally, to solve for x, I'll divide both sides by 0.5. And 20 divided by 0.5 is 40. Okay. So, like the doesn't really give me what this represents, but the price that makes the elasticity equal to 1 is 40. Okay. Part C says, at what prices is the elasticity of the demand elastic? So going up here, remember it's elastic. That's part 3 of your definition up here. The demand is elastic if E of X is greater than 1. All right. So say the demand is elastic if E of X is greater than 1. So basically, well, let's see. 0.25x. Ooh. You just set that greater than 1. I'm having a moment here because that's not just a trivial solution for that. That's yeah, that's what we call a rational inequality. Oh man. So to solve this, we would need to subtract 1 from both sides, get a common denominator. I'm not going to make you do this, so don't worry. I'm just explaining why, it's not important to me that we do something like this. Because this is what I would have to do. I would need to get, like I said, get a common denominator, which means rewriting that 1 with a denominator of 20 minus 0.25x. I'm going to finish this just because I've gotten this far, but I will definitely go into the homework and get rid of any questions that ask you to do this, because like I said, this is a little above what I expect in this course. Okay. Whew. Okay, now adding, I'm not even going to finish it because it's a bunch of algebra. Uh-oh. Let me bring that down here. Adding the like terms. .25x plus .25x is .50x. So basically, once we get it like this, I don't know, those of you that took college algebra may remember solving this kind of problem. This is a rational inequality. Like I said, it's not as simple. It's not really straight. We've already done a lot of stuff that I don't really expect you to do, but at this point, we would actually have to make a sign diagram. It's messy. So we'll just live without this part, okay? And like I said, as soon as we finish, which is going to be momentarily, we could do part E. But I'm not going to have you solve these inequalities. So let's skip those two parts and let's go to part E. At what price is the revenue a maximum? So that happens, remember, when the elasticity equals 1, and the elasticity is way up here. Oh, we already did that. Okay, I already did that. So at what price is the revenue a maximum? Okay, so it's the same as the result from part B. So we can just say that when E of X is 1, we said X was 40. So revenue is the maximum. When the price is 40, I guess $40. And again, I got that from part B, where we saw E of X equal to 1. Okay. That's pretty much it. Does anyone have a question? It was kind of, like I said, there's a short section. There's not, well, there's not a lot of calculus in here, but it just involves getting the derivative of the demand function and then using that formula for E of X. All right. So let's see. All right, so that actually finishes 2.7. I'm trying to, my schedule isn't, I don't have all the schedule here, but our next test is when? Does anyone know off the top of your head? Let me see. Because I've got the schedule printed through November 9th, so I'm just looking at that. That's a lot of material. So I may change the date of the next test. Let me see, I've got my syllabus up here. Goodness. Let's see. Yeah, so I have test 3 basically covers the rest of the material in the course. So I'm going to think on that a little more. I may change my mind on that. But we got a little while to talk about it. Okay. Does anyone have